Hello, welcome back. In this section, we will talk about license assisted access, or LAA as it is known in literature. So, you may ask, why is LAA needed? So, let's give you a good reasoning why the industry is pursuing LAA. Spectrum is not an infinite resource, and as spectrum needs used by already deployed wireless systems, both commercial and non commercial, cannot easily be revoked, regulators worldwide have therefore started looking into alternatives to use the available spectrum more efficiently while exploring the concept of shared spectrum. In the meantime, the cellular industry, led by several network operators, infrastructure vendors, and chipset manufacturers, have eyed unlicensed spectrum, particularly the 5 GHz ISM band, which is the industrial, scientific, and medical band, to serve the immediate need for additional spectrum for mobile broadband applications due to the ever increasing mobile data traffic. The ISM bands are generally defined by the ITU but are regulated differently by each region. The exact frequency allocation and detailed regulation depends on the country. So, to give you some context, as we have seen so far and are witnessing, all the network operators are being faced with a very big challenge of meeting network capacity because of an increase in traffic. And given that the spectrum is limited, that they own and is very expensive, they have been looking at other alternatives on how they can increase capacity of an existing LTE network. And one of the easiest ways to do this is by leveraging the 5 gigahertz band, which most of us know as the Wi Fi band. It is actually labeled as the ISM band, and it is free for anyone to use as long as they meet certain criteria as laid down by the Wi Fi Alliance and also the different regulatory organizations within each country. So how do we use the 5 gigahertz spectrum? So you can use it in essentially three ways, and we will look at those ways here in this slide. So imagine you have a eNode B that is operating on the licensed frequency. Then you may have an eNode B that is running on unlicensed frequency band. It is also transmitting LTE, and then you may have a Wi-Fi access point, which is running on the ISM band. Now, if you wanted to do LWA or LTE wireless WLAN aggregation, you could take traffic you could use some sort of link aggregation by combining your links from the 2.45 gigahertz ISM band into with the eNode B license band and do something like an LTE WLAN aggregation. There are two flavors of it that are adopted. There is the LWA, and then there is a LWA with IPsec, where you will have an IPsec tunnel between your core network and the Wi-Fi access point, and you can do that. The most prevalent um, that has taken effect and is referred to as LAA and eLAA is where you actually perform carrier aggregation across an A node B in the licensed frequency band and an E node B in the unlicensed frequency band. The licensed frequency band is your primary cell, and then the unlicensed frequency band is your secondary cell. And this can be activated or deactivated depending on the need or traffic demand. So, this is the more um, widely adopted carrier aggregation. Actually, 3GPP made a new LTE band just for 5 gigahertz, and it's called band 46. That is so when you look at UE capability messages, you may see support for 46 in certain UEs. The third is wireless LAN offloading, which is again a way where you, rather than sending traffic over a E node B, a licensed frequency carrier, you take that traffic and you push it over Wi-Fi. This was a strategy that was adopted by many LTE operators in the beginning when they were seeing the crunch um, for the capacity, and a lot of operators actually deployed commercial Wi-Fi, and they were doing wireless LAN offloading. So the main focus here would be LAA and eLAA. Looking at the 5 gigahertz IEEE channel assignment for United States, you can see that the frequency range, this f start and f stop, are these numbers here. So there is quite a bit of bandwidth to play, but you can't use all of it. There is some um, stuff like weather radar that you don't want to interfere. In the US, the FCC has has identified Uni 1 and Uni 3 sub blocks of LAA that can be used, and actually they can be used in Korea, India as well. And if you look at these bands or these blocks, you can either have 420 megahertz carriers in each of these sub bands, or you can have 240 megahertz or 180, you know, 180 megahertz um, uh, LT carriers. So the idea would be that you have a licensed eNode B, and then you have eNode B operating on 5 gigahertz spectrum, and they operate in conjunction, where the 5 gigahertz LTE would be a S cell or a secondary cell and would be turned up and down depending on the demand from the subscriber. The way you choose each of these channels is dependent on certain criteria, which you need these channels to be available and not being used by other competing devices. Only then can you use them for LTE. Now let's talk about eLAA, or the enhanced version of LAA. Enhanced License Assisted Access is part of 3GPP Release 14. It defines how user equipment can access the 5 gigahertz ISM band to transmit data in the uplink direction. So LAA that we looked at before is purely for downlink, whereas eLAA is for uplink and downlink. The first major difference to LA is that generally all uplink transmissions in LTE are scheduled and therefore under control of the serving LTE base station, eNode B. Since this affects the channel contention between devices, the required LBT, listen before talk scheme, that was defined in LAA for downlink operation needs to work in the uplink direction. The second major difference is that the regulatory requirements that have to be fulfilled while using the 5 in band in certain regions. For example, the European Telecommunication Standardization Institute (ETSI) mandates that occupied channel bandwidth shall be between 80% and 100% of the declared nominal channel bandwidth. As an initial approach, multi-cluster physical uplink shared channel operation standardized in 3GPP Release 10 was considered to fulfill this HC requirement. However, it was soon realized that it's not a very good way of allocating resources. So in ELA, what we do is we use it for uplink, and we allocate eLAA and bring it up as a SL for uplink carrier aggregation with an LT anchor carrier, and we are able to provide uplink CA as well. Um, the eLAA has not been that widely adopted as of yet. There are certain challenges, as can be seen here, where the industry is trying to see the most efficient way of allocating physical uplink shared channel resources in the best possible way because of certain requirements as laid down by HC. LAA, however, has seen a lot of traction from the industry, and it is working pretty well for traffic hotspots ELA is going to be adopted relatively shortly after these challenges are resolved and the industry as a whole comes together.